Yeah, everyone. Again, thank you for coming. Don't forget to help your chair when you leave the room. It's really noisy. Don't pass in front of the camera over there. And we still have JetBrains licenses, so open pull requests. Then I'm happy to introduce Nishant. He's going to talk about Kotlin MP into the multiverse. So please give him a big round of applause.
Okay, hello everyone. You can all hear me, right? At the back also, I hope. Okay, great. Thank you all for coming to this talk. So the idea about this talk basically came through because I was trying to find out ways of working with Kotlin multi-platform, as people have been talking about it, and a lot of things are going around this. So I eventually started trying out how I can get this to work. Turns out it's not as easy as we think it is. So that's how this talk came to be. So what I'm going to be doing here is I'm going to try to at least convince you all to understand how Kotlin multi-platform in general is working and what it's doing. And then I'm also going to show you how you can actually get a working application for Android and iOS, because it's not as simple as you think, like you just fire up an IDE and it works. No, it's not that. That's what I will show you. So let's start with that. So I said Kotlin MP. What does that actually mean? As you would have guessed, it's basically Kotlin multi-platform. There's no formal definition for this, like what exactly it is. So I came up with my own from what I understood. Basically, we are utilizing Kotlin language to build for these multiple target platforms. I'll get to what target platforms are in a few minutes, which enables code sharing while being as flexible as you can be, right? So I'm going to break this down because like a full statement, okay, there's a lot of things being said here. In general, Kotlin multi-platform is like an open source tool, or I should say plugin that's available. It uses Kotlin as your common code here. Also, it's targeting multiple platforms. The code sharing is specifically happening for data, domain, and presentation layer. The different thing about it is that it integrates with the existing native platforms. So it leverages the native capabilities of the platform when it is required. It's not that you are specifically forced to use them. It's more a choice on you. When you need to use them, you will go ahead and use them. It's optional, as in it's not opinionated. Ties into the same point as above. It will not ask you to specifically use a certain pattern. It will not ask you to do some sort of trickery or use a different language to work with. So it's basically trying to help you as much as it can while giving you all the choices. But the question here is why? Why are we even trying to do this? So from what I understand is that up till now, there have been all these different possibilities that we could use Kotlin for. You could use Kotlin for generating JavaScript code, and then you could use Kotlin for generating the JVM base code, the bytecode, right? And then Kotlin native came into place, and that allowed people, or at least the Kotlin toolchain, to generate more target platform specific code. So you can think of something that's more near to the machine level code here. And the second point that's very important is that existing solutions are very opinionated. I'm looking at Flutter, React Native, and then you also have Xamarin. Obviously, people have tried C, C++ in the past too. All of these are very opinionated in the sense that they force you to use a certain pattern. Flutter would basically ask you to use, first of all, a different language, so you start from a different stack and a different language. At the same time, it tells you that you cannot use the platform widgets because it is going to be drawing all the widgets for you on the screen, right? So those kind of opinionated versions exist, and that's why Kotlin native is, or Kotlin multi-platform now is something that's more considered. It's something like this, we have a situation where it's a dilemma of the mobile app development right now, where if you want to develop a native app for each device and maintain several projects, this is what it looks like on the right. And then you use a unique framework like, say, PhoneGap, and then App Accelerator like in the past, or you could use Flutter or even React Native. You end up building something that is limited in functionality. Why am I saying that? Because there have been companies who have tried this in the production. Like, for example, Airbnb tried React Native, and then they pushed back to going to native again. Dropbox tried CC++ for their cross-platform capabilities in the application, but they also went back to native because there's certain things that you cannot do when you're trying to share most of the code across platforms. So let's dive into the multiverse of platforms here, or target platforms. That's the technical word for it. The way I understand target platform, I think this was explained in the last talk a little bit, but the point here is that I understand it as compiled artifacts to be consumed by a specific platform. So say, for example, when we are considering Kotlin JVM, the artifact that will be consumed by the platform would be jar and AAR files, right? This can be consumed by Java, by Android, by Spring Boot. If you have Kotlin JS, it's going to be generating JavaScript code, which you can bundle it up and push it with, say, JavaScript, React, or Node. And then there comes the Kotlin native part, which enabled more possibilities, where you have ability to generate code that is native to the ARM platform, or so CPU in general, that you can push it with the Android NDK. You have iOS version. The iOS x64, by the way, is the emulator. Similar you have for tvOS. x64 is again emulator version. watchOS x86 is again for emulator. And the other versions are when you want to run them on the device. And then you have more, where you have the Linux ARM version, the MIPS version for the same macOS x64, MingW, which is basically for Windows, and then the WASM32, which is for WebAssembly. That's what Kotlin Native is allowing you to target now, because it's generating artifacts that can be consumed by code that's running on this platform. So this brings me to the next part here, because it's not just the target platform, it's also about code sharing. So when we say code sharing, we are actually talking about more related to the data layer in general, right? Where you can put your networking code that can be shared across multiple platforms. You can put caching, you can put repositories. You can even put like something like a presentation layer, which is common on Android side. You have view models and presenters, controllers, and then there's the domain layer where you can put use cases, entities, and the interactors. What is also important here is that we are not talking about the UI at all. Now, why we are not talking about the UI? Because Kotlin Native in general doesn't even care about UI. Each of these platforms that exist have their own way of representing UI. iOS has its own version, Android has its own version, say example, Linux has its own version, and they all do their job pretty well. So what Kotlin Native is basically saying is that we're going to build an artifact for you. You plug that into your application, build the UI on your own, and then use this whole code, right? So this is the artifact that is being generated on all of these different platforms is what is shared, but the UI is still native. This is more or less on the side of just making sure that the UI gets updated pretty frequently, right? But your business logic anyway stays the same. So you want to share your business logic mostly and not the UI. UI can change whenever you want based on whatever technology you use. Even say, for example, on iOS, we were developing a lot of like UI with, say, view controllers and other stuff. Now you're using the Swift UI. Same on Android, you could basically be using XML layouts now, but now you have Compose that's coming in. Now these technologies would change all the time, but the core idea of multi-platform here is that the business logic is getting shared across. Mind that I'm not saying this is cross-platform. Comes back to the same thing. When we say cross-platform solutions, we have basically solutions that they are asking you to write code in an opinionated manner, right? Also, they are doing some sort of like bridging to make things work for you magically, right? When you say it's a Xamarin app, I write code in C#, and I write something up in, say, for example, like an application in that, and then I deploy it to, say, Android, iOS, and, say, some other platform, maybe desktop. In this case, what they're doing is they are going to compile your code, put it behind a bridging layer, and then talk to the native side. So there's still some sort of a dependency in between. If this dependency is not updated, you're already behind. So what's the secret sauce here? So from my understanding, and this is what I am going to maybe represent it, and maybe you can think through with me as I explain this, is that there's a concept called expect an actual concept, what I like to call as interfaces with superpowers and more. and I'm going to explain what that turns out to be. So this is a standard interface in Kotlin, right? You have an interface that has a function called platform name. Then I'm using Android code right now. You have a main activity where I'm I'm not extending the activity here for some reason, but I should have. Anyways, consider it's a standard class that is implementing the interface, and it overrides the function here, platform name, because I'm using the interface. And then later on, I use it inside the function called create application screen message. I'm calling it hello from $, and then passing the function in there. Now, notice here something. The first section where the interface is declared, or I should say defined, actually, or declared, yeah, that is the point where we are expecting this to be implemented. This is how we read it, right? And then eventually when we override it is the actual implementation. That's how interfaces work. Now I'm going to map this back to how Kotlin multi-platform is going to be using this kind of a functionality. So what you have is that on your, say, you have multiple modules right now in a Kotlin platform project. The common module here would basically say expect, that's the keyword to use, and then it will put it something similar to like how you use coroutines. You put suspend and then the function name, right? You're going to say expect the function name, and then that's it. Then maybe you can use the same function call in the common code for create application screen message. And then eventually in the platform specific code version, you will go and say the actual implementation for this by using the keyword actual is this function, and what is the implementation you want to define. So in this case, we are defining the string as Android for Android platform module and iOS for iOS module. But that's not it. And I said and more with the superpower version is because it's not just limited to how it will work with functions. You can use the same kind of a process when you're doing it with a class, right? So for example, you have a class here, greeting, where you say, I'm going to expect this class to have a function called greet in it. Now, the platform implementation for this will map into saying actual, the class greeting, and then notice I say actual constructor val name string. Why am I saying actual again? Because on the platform side, this could have been, say, Swift, and it would have said let name string. So this is also changing for me. So that's why I have to say the actual implementation for the constructor is going to be something that's very specific to Android, in this case using Kotlin, so val name string. And then eventually I provide the actual implementation of the function here called greet, where I say println hello name, and then you can obviously use it based on which platform you're using. In this case, we are considering Android, so we'll create the class, we'll call the function on it, which will print hello FOSDEM. So that said, let's jump into trying to, or I'm gonna go through the steps that you require to start building Kotlin multi-platform code. Now that we know the idea of expect and actual, but before we do that, I want to mention something about sharing is caring. So if you go on the internet right now and you try out like Google searching this, how do you get a Kotlin multi-platform project to work? You find many ways. One of the ways of doing this code sharing is that you put all your code in just one repository, right? And then everyone just tries to work with that in that same repository. That's okay-ish to work with, but if you have many teams working across different time zones, people are going to be committing code, it's going to conflict and cause a lot of problems. So that's not a good one. The second one is that you put everything in its own repository, in its own project, while the shared code that is going to be shared across multiple projects is going to live its own project. It's a bit hard to maintain because you have to keep in sync with the shared code and the other platforms that you are sharing this against. So you have to keep them in sync. This is what it kind of looks like. So imagine this being a project in IntelliJ where I am basically creating a sample app called KMP here. It has app as the module, that is the Android app. It has native/Kotlin iOS/Kotlin iOS as the iOS app module here. And then you have a shared code as a full folder here, inside which lives something called Android main, which is your Kotlin JVM code. Something that lives as common, which is your shared code. And then you have your iOS main, which is your Kotlin native iOS shared code here. This is basically living outside in a shared code folder. So this is something that you would do, but it's really hard to maintain it at the same time because, yes, people would be doing a lot of things at the same time. The third version of doing this is that you have one platform in sync with the common code while the other one lives on the other side, right? So it's better, it's easier to test with, it is better to change things, and this is what it looks like. You have something like this, you have Android app and the Kotlin JVM version living side by side. And then you have your shared code, the Kotlin native iOS code, and the iOS app as a different module, right? The shared code and Kotlin native iOS code actually lives inside the app module. As you can see, it's called common main and iOS main. This is just living inside the app module itself. So we're going to actually start doing this like from scratch, like how you would do this. You would think that it's very easy to work with, but sadly there's no specific ID like Android Studio. But we use kind of like all three IDs here. We'll use IntelliJ IDEA, we'll use Android Studio, and we'll use Xcode. All three of them together to get this project working and functional. So you start with IntelliJ IDEA. This is the latest one. I took the screenshot last night. You create a new project. You say, I'm going to put a mobile multi-platform project with Android and iOS code in it using Gradle build tool. Define it a name, give it something, and then say finish. At this point, when you've hit finish, your project would sync, and you would ideally assume that it is functional. Turns out it's not, because by default, IntelliJ IDEA does not put the SDK path for your Android in the local.properties file. So that is a bit weird, because they do that for Android Studio, or maybe Android Studio team does that specifically. I'm not quite sure. But in that sense, you will have to actually provide the path here. So I changed this path to something called users/username, and then I provide the Android SDK path here. When you do this, your project is fully functional. At this point, what you do is that you need to also go into your project structure and set the default, like the SDK for all the modules. This is also something that I don't know why it doesn't work, but ideally this should be supported from the IDE itself. They know there's other SDK, but they don't choose the default one as 1.8 Java version. So I want to also highlight here, when you do this, the wizard version, you actually see something like a common code, the Kotlin native iOS code, the Android and the Kotlin JVM code, and then there's the iOS specific code, which is all split into different modules right now. The function calls, as you will define, you will mention them as expect in the common code only. In the Kotlin native iOS code, you will provide the actual implementation. In the Android and Kotlin JVM code, you will provide the actual implementation. The magic behind how all of this is tying together is actually using this plugin that you have. You just need to, it is defined in your apps build.gradle file. Once you define it, you all have functionalities open like these. You can define the platforms you can target to. Under the section Kotlin, you can say iOS x64, which right now is targeting the iOS emulator. I could just go ahead and do TV OS x64, and that would do the same thing, but for the TV OS operating system for the emulator version. And then you define the source set, basically defining your dependencies, which you can totally do as you would do in a standard Gradle project. Then, because you now want to run your application, you set up the project, now you need to open up Android Studio and select the app module, the one that has your common code too. You will select that, run this through. As you can see, there are different modules it's recognizing. And then it will be able to execute the application super easily. That's nice, because now we are going to try doing this same with iOS. So with iOS, again, you go and then you select the folder that is called iOS app. This is outside your app module in your root project, and this is the one you need to select. When you do that, you would assume everything would work, but it does not, again. Turns out that's because they use a relative path to reference something that doesn't exist. Which is also weird. They should not do this. It should come part of the wizard, but it's not. So you have this error. This error literally says that you have something that's missing, and that's a Gradle U file, right? That's not there. So I need to put a Gradle wrapper in the root project. And I'm going to do that by calling Gradle wrapper, and it will create that for me. That basically allows me to go back into Xcode, hit run, and be able to run the app at the same time. So now you have an app running on Android and iOS both. Basically, the whole project is functional. You can go ahead and write code using Android Studio if you want, or IntelliJ IDEA. You can just open up the Kotlin file, provide the actual implementation, or the more expected functions you would want. So examples in the wild. I want to show this because there's a lot of questions going on. Do people use it in production or not? Like, is this something that we should not be tinkering with? Turns out a lot of companies are doing that. You can see a list of them all working with the links. These all links to their blog post, actually. When you download these slides, you can use them and read what they have been working on. JetBrains has recently released Spaces, their whole this system here, which allows to communicate with multiple teams. So that is also working Kotlin native, Kotlin multi-platform. And obviously, TouchLab is doing a lot of things in this area, so you should totally follow them. There are Kotlin multi-platform libraries, by the way. You can get a list of these. But here's the caveat here, is that the ecosystem is still evolving. The bigger problem is that not many libraries are available at your disposal. And a lot of people, those who are jumping into building these libraries, are actually not targeting all the platforms. For example, you wanted to use a multi-platform library right now that targets, say, or kind of like does database saving and retrieval of data, right? But it does not target tvOS, but you wanted that functionality and be targeted to tvOS. Well, if the library doesn't support it, it's useless for you. Right? You can target 4 platforms, but not tvOS in general. So that's why not all libraries are actually targeting all the platforms. So that's a bit of a problem. That's most of the stuff. There's a resource here. This is like a, I would say, a tutorial. The first thing is more a tutorial on the official Kotlin Lang site. The second one is the example that I showed you. What I do want to also show you is the thing that I was talking about. This is how all the files look like and the implementation. This is the same project as I was talking about. There is a section where I actually call this function, create application screen message, which was running there. And I provide the actual functionality here. But some people might even say, like, what if I wanted to use SwiftUI? That is also possible, provided you use it in a different way. In this case, you will see I'm including the shared code functionality, the one that I was explaining way earlier than this. And then I go ahead and I actually call the function here with the common KT file. So you can also use with SwiftUI if you want. If you have Compose, you can also use this work. It should function without any problems. I will put more examples in this repository, so you can also obviously follow this along. And that's it, I guess. Thank you.